minutes ago, so this is going to go great. Do we need to talk about this?
No, those were for us. You weren't supposed
cool.
to see that.
Oh, all right. All right. Oh, Waylon, you want to talk about this one? This is your stuff.
Oh, wow.
There's TV
I'm
right
changing
there.
the order as you're going, so I guess that none of those made it.
I don't know. I can refresh it.
Oh yeah, that's always slide 8 now.
There you
go
go.
with that one.
Yeah, you start.
Cool, I'll start.
There's TV right there.
Okay, great.
All right, so for those of you that haven't gone down to the HHC, I've got this exploded version of the badge, so you can see all the internals and the layers and whatnot without taking your badge apart. Please don't take your badge apart. It's really easy to damage the internals, damage the screen. We don't have extras. But yeah, it is 4 PCB layers. There's 5 actual PCBs because, you know, the one part, the shackle slides, so it's separate. One of the really big challenges with this is the thickness limitations inside the badge. So a layer, normal PCB thickness is 1.6 millimeters. It's not much to work with. And in the center we have 2 layers. So we got 3.2 millimeters to fit everything inside this badge. The screen is 2.6 millimeters, which means all our components have a height limitation of 1 millimeter, which is ridiculous. It spent so much time searching for chips and everything, and especially with the chip shortage, trying to find stuff that would fit was a huge challenge, and we redesigned and redesigned, and we'll go into some more of that later. But yeah, that was a big challenge with the hardware. By the way, I wanted to do USB-C. The USB-C connector is more than 3.2 millimeters tall, so we couldn't use it unless we wanted a third board in the middle, and that wasn't going to happen. So budget, $30 a badge. And we accounted for tariffs this year, and so we actually hit our budget. And yeah, they were assembled in the US, a really awesome company called PCBX. They're in Ohio, and so yeah, they did the assembly for us, which worked out really well, so we didn't have to try to communicate with an offshore company and try to send parts there, and yeah, having a US company do it is amazing.
Okay, so the badge has a few games on it. I think the obvious one is the one on the right, where you scroll around and dodge, I don't know what they are, coronaviruses, and pick up blue energy balls. I don't know, whatever you can call it. You can pick up the vaccine as you dodge the corona, whatever, and you're in a spaceship. Make up your own story. And then the one on the right, the left, is actually a serial port terminal game. So if you connect to it over a CDC connection, then this is a old school roguelike turn-based game. And so you use the arrows and the space key to move around and try to sneak through this building without getting seen by the guards. So a lot of what a lot of questions we get is like, what is this machine? This is a finished version of that machine. When you have options to build parts with your smaller parts, this is what you're trying to build. This image is a little older because it's got the older SAINTCON logo. We redid it when they redid the SAINTCON logo, but this is what you're trying to build on your badge. You can go on. And then you can build that, like you'll get parts rewards for entering different combos. There was a combo on one of our earlier slides, and you'll end up with a lot of parts. Hopefully, I mean, you probably won't end up with exact parts you need, but you can trade. You can go to the trade screen and trade badges or trade parts with other users to get what you need. However, go ahead. However, there are some bugs with that. Some of you have been blessed with 255 of some of the items. That's the EEPROM deciding not to save when I write to it, and when I read from it, it just gives me FF. So you guys benefit from that bug. Unfortunately, there's also a bug with the trading where sometimes one badge does not want to finish the communication, and the other one assumes the communication is complete. And so one side will complete the trade, and the other side won't complete the trade. So that means one person doesn't trade anything, and the other person gets a free item and loses something to the ethereals. So I'm sorry about that one. We may have a bug fix for that one, but that would require reflashing all the badges, and we are not going to do that. So it'll be in the code base when we release the code. That's a CopyKit point. Okay, go ahead.
Was this for me?
I'm
All right, so yeah, we talked about chip shortages. I redesigned the hardware on this 3 times, I think. So a little bit of backstory. This was the badge we planned for last year. We designed it last year in April and May, and then the decision was made to have a virtual conference, and we didn't want to waste this badge on the virtual conference because it's meant for interaction. So we kind of shelved it this year. We picked it up again and couldn't get the same chips and redesigned, and it was a mess. So we had some features that we wanted that we couldn't get. Like we wanted an accelerometer in it. We couldn't get any when we went to go build the badge. We can get them now, but that's not helpful.
Yeah, so with that redesign, like we planned on 2020, we got a lot of the dev work done, and then we got a new chip, and the new chip required a new development environment, and that new development environment did not support C++. So we had to rewrite a lot of the object-oriented code to be raw C code, pure C code, to support this different processor. Also, when we redesigned the chip, we used a different flash chip, and we realized that our new flash chip did not support QSPI, which would allow us to memory map the flash and just be able to read it. Since we couldn't do that, we needed to the display to read from memory, right to a frame buffer, and then write that to the screen. That needed to be as fast as possible. And in our tests, we were only getting 10 to 12 frames per second, which wasn't fast enough. And so this is a picture of me looking at the assembly code in that frame draw function. This loop is where it's throwing stuff to the screen. And I was looking through there, counting each instruction, like, oh, that multiply instruction is 4 clock cycles. This, load instruction is 2 clock cycles. And like counting them, like, okay, I can move the multiply outside the loop. I can move this outside the loop to optimize that draw frame. So we did some hand-rolled assembly to improve the frame rate on this.
All right, so this is one thing I ran into on the first new prototypes this year. So if any of you have dealt with any kind of chips and whatnot, there's a thing called an errata sheet. And that lists all the problems with the different versions of silicon that the manufacturer has produced. And it's not tied to the data sheet, it's not part of it. You have to go search this out separately. And I failed to do that. And there was this nice little note in there that says the internal pull-up resistor for the reset line on the chip doesn't work.
Small bug, not a big deal.
So our prototypes had scabbed-on resistors to make them even work. So yeah, all kinds of fun stuff that you find. Here's some pictures of assembly. Yeah, lots of soldering. We hand soldered the screens and the battery packs and the mini badge connectors. Yeah, so much assembly.
Oh, this is my turn.
That's
Woohoo!
yours.
I finally get a slide. Maybe I should have helped with this. So for the NFC, we wanted a way for you to be able to go around the conference, do something, and then get an unlock for it. And so the way I came up with is I had these little PVC coated tags. They're like knockoff Chinese versions of the Amiibo tags. And so I designed a cool SAINTCON 3D printed thing, and then I printed one of them. I thought it looked really nice, and I was going to do a huge batch of them because it requires you to pause the print to put the tag in, and then pause the print to change the filament to get the cool dual tone color. So I decided to do a batch, and then the more I thought about it, I didn't want them all to look the same. So each one took about an hour and required me to be constantly there. And I decided to do this last week. So I printed this many tags. They helped a little bit, but yeah, it took way longer than it should have. They look cool, but yeah, I would not recommend starting a project for SAINTCON the week before SAINTCON.
We don't have a slide on the NFC. I think you should talk about that too.
Okay. Yeah. And so we used, it was an STM chip for NFC, yeah. And They had some data sheet that talked about the communication protocol of how to put things on, well, how to tell the NFC chip what to do. But the real issue with that is it says, here, send these bytes. Well, if you know anything about NFC, you have to know what bytes to send and what frequency to use, the channels, things like that. All is supported by the chip, but it doesn't tell you what exactly to do in the data sheet. So to understand how the NFC worked, we had two options. I learn everything there is to know about NFC and write a custom library, or we can use their provided code, which was poorly written and not documented and would have taken a lot longer than understanding how NFC works to just get through their code base.
Yeah, their code base was like, here's a sample to detect a tag. And they're like, well, you do with it past that, you're on your own, bro. But there's a tag there. And so we struggled with trying to decide to use their library or start from scratch. And Sodium here did the start from scratch.
We did start from scratch. There was also an issue with their library where the chip has a lot of weird bugs in it. For example, talking to it to send an acknowledgement packet in NFC requires a specific command. If you send that command the way the datasheet tells you to, it doesn't work. So the option is to dig through their code base, find the one line that uses a reserved for future use command. So it's not even documented on how to send an acknowledgement. And then another issue with that is a lot of the timings were just wrong in the data sheet. So a lot of stuff just has to wait a lot longer than it should because the chip just doesn't respond. And sometimes the chip gets in a state where it just can't recover and it doesn't tell you it's broken. It just acts like it's still there. So
Mike, wasn't this chip like a redesign of a previous chip?
Yeah, it was kind of weird. They had two different chips, one that could read and one that was a writer, and then they kind of combined them into this other one. But yeah, there's like multiple different revisions that changed names in the middle, and it's a mess.
And it really feels like they just like took the two documents and like put them together and like, oh yeah, that's totally how this one works.
Yeah.
But
it's not.
So do you want to talk about the antenna too?
Oh man, I wish I had slides for that. So designing an NFC antenna is not for the faint of heart. And even though it's not actually RF, it's induction based, it's still a mess. So I used an online calculator to say, okay, I've got this many turns, this diameter, this thickness of copper, and it's like, yeah, it should be this, this many microhenries and this resistance. And so then you design your matching capacitor network for the NFC chip, and you put it all together, and then it doesn't work. And then I got a vector network analyzer to test the antenna and see what it actually came out as, and it was way off from what the design tool said. So then I redesigned the tuning network again, and it still didn't work. So it ended up being just hours and hours of trial and error, changing out capacitors, seeing what works. The network analyzer turned out to be fairly useless, actually, because if any of you have seen how that works, and with the Smith chart, and you get the little loop, and you're supposed to put it right in the middle, when it's right in the middle, it doesn't work. So it ends up being way off in left field, but it works now. We also ran into issues with different phones have different NFC abilities. My phone, apparently it's a Samsung Galaxy something, happens to be fairly good at NFC. And so even with a weirdly tuned antenna, it worked great. And these guys' phones didn't work at all.
I have an iPhone. It's useless.
So yeah, there were all kinds of issues with that. And especially with Sodium being not living up here, it was fun trying to ship badges back and forth and try things. And
between like the redesigns and getting the antenna to work and trying to write our own NFC driver, I think it was a week ago that we finally got the NFC working and ready and threw that in the main branch. So we had like 2 days to test the NFC and make it go.
Yeah.
It was kind of terrifying to be that close to the conference and not have working NFC, which was the main point of the badge.
Yeah.
And another issue was the only way to know your NFC commands to this chip is working, because again, the data sheet was terrible, was to test it. And so a lot of the stuff I did blind, and then it didn't work. So when he finally finished, when was the final design shipped to me that I could actually read?
2 weeks ago?
Yeah,
Yeah.
most of the NFC has been written in 2 weeks.
Yeah. All right, this one's yours.
And then so in the past, there's always been issues with mini badges talking to the main badge. It hasn't worked very well because the first year there was a thing saying we have SPI and I2C, and well, the badge didn't do anything with it even though it was connected. The second year, he published some documents on it, and then they got working and realized that it didn't work very well, so then they changed the spec a little bit but forgot to update the public spec. So then people showed up with mini badges that still didn't work and would crash the main badge. And then this next year, so the Enigma badge, he made it work in theory with some devices. It still followed the spec a little bit from the previous year, but just a little bit. And so people's mini badges didn't work again. And so I decided there needed to be something about that. I joined the badge team. I decided to do this to myself and redefine the spec and wrote a ton of example code of how to get a mini badge to talk to the main badge.
Yeah, and when's your...
Today at 1 in Cascade E, I'll be talking about how to get that communication working and a great tool that I made and got delayed in China. So I have some. They'll probably be in the store tomorrow at the rate we're going.
Yeah, so you created this really cool dev board for designing mini badges and testing communication and all that good stuff.
So you can verify your design before the conference, and as long as it works with that, you should be confident that it'll work with the badge as long as the badge talks.
Yep.
And then we also added the clock pin, so that's a little bit of extra software. We did that, like
Sunday.
Saturday? Oh, Sunday? Yeah, we got that working on the badge Sunday, but it was pretty easy. But then now you can have interactive mini badges. Overall, there were some nice changes because it made it so we had to care about less on the mini badge spec because a lot of the code was written beforehand. So that made this nice.
All right. Is this the last slide? Yeah. Okay, so I have a video for you guys. So last year, when I was designing the badge, I decided to screen capture my design process. So this goes through the first 2 prototypes that I did last year. It's about 30 hours worth of video. And it's condensed into about 5 minutes. So I will try to kind of talk about this as it's going. So Fusion 360 is how I designed the board stack and everything. Got that out and put that into KiCad to get the outlines and everything. One thing you'll notice as we're going through this is me scrolling through data sheets. So many data sheets. I mean, the main chip the data sheet is 1,500 pages, something like that. And then there's all the other chips that have their 100+ page data sheets, right? And so much time, so many data sheets. At one point, we were looking at a physical switch to detect the shackle opening and closing. We ended up scrapping that idea because trying to find a switch that has a long enough travel without you being able to crush the switch when you're opening or closing it is tough because you have to have fairly loose tolerances with circuit boards and their outlines aren't always perfect, and trying to get something to fit with that was a challenge. let's
I
see.
saw Slack Overflow in there.
Oh yeah. Yep, so, all right, this is when I actually
There's
started
your rat's
getting
nest.
into
I see
laying
that.
out the board. And just constantly back and forth to data sheets.
It's sad because a lot of these parts that you're referencing here aren't in this product anymore.
Oh, I know, yeah, this was last year, the first design that we basically scrapped.
So you had to do this all again.
Yeah, I kept the, the board shape and outline and everything, and then replaced all the electronics. Yeah, and here again was trying to fit everything within that 1 millimeter thickness under the screen.
Oh,
Right.
tell me, so the accelerometer never made it, but you want to
Oh,
talk about the
yeah.
hairdo you had to do on the,
Yeah, so when we were first designing this, right, I had measured the screens and everything. And I'm like, okay, I got 1 millimeter. And the accelerometer I could find at the time was 1.1 millimeters thick. It's like, okay, we'll try it on the prototype, right? It might work, might not. Stick the screen in, and it's got a big spot in it where the accelerometer was. So I was like, I wonder how thick the case on the accelerometer is. So I took sandpaper to it, and I shaved off 1/10 of a millimeter off the top of the accelerometer, and it still worked. But there was no way we could do that on 1,100 of them. So we scrapped that, and then, yeah, this year we couldn't even get accelerometers.
just for an idea regarding like the chip shortage, like you guys, I'm sure you guys hear it all the time, right? I have a pallet of like 50 of these STM F10 somethings, and when I bought them, they sold for like $1.03 each. So it's like, $50 worth of chips. But last year, I looked online and they were selling for $26 each. And it's crazy the markup on these chips. Like they just disappear, right? And they cater to the large vendors first. So like badge makers like us who only want to buy 1,000 to 100 of something, we're kind of the lowest guy on the totem pole, and it's difficult to get what you want. I was talking with a aero vendor the other day, and he was telling me one of his chips is 72 weeks lead time. That's a year and a half.
Yep.
Wait, I think that's more than a year, isn't it? No,
Yeah.
52 weeks, yeah, year and a half.
Yep. All right. So this was my second redesign where I went through and changed everything. Yeah, that's the touch wheel on the front. You can see the rings for the NFC antenna out there. All right, I guess that's the end of that. By the way, designing touch wheels as well, not super simple. I designed this one, it didn't work well at all, and then I designed the new one, and it was close enough, and we didn't have time to redo it. So there's a really ugly lookup table in the badge for the touch wheel that makes it a little more linear. But if you'll notice, if you're playing with it, there's some big jumps as you're going around because there's just not enough resolution in the touch controller. And the design of it, we really just needed more than 3 segments. And
Didn't we use every single pin the chip had?
every single pin is used on the chip. And speaking of capacitive touch, if any of you have looked at the exploded one, you notice the shackle opening and closing, there's no physical switch. We used capacitive touch for that. So if you have a chance, go down to the HHC and look at it. There are 4 capacitive touch pads on the bottom board. There's some matching ones up on the shackle. And there's also an extra one in there that's not part of the shackle. You guys should take a look at that and maybe see what can be done with that. Do we want to talk more about that, or is that enough of a...
That's up to you.
Push.
You may give him a little more. It's Wednesday.
Yeah, so, there's lots of soda cans lying around, and it's a really nice thin piece of metal. and there may be something in the badge that could be done with that. I mean, it is a lock, right? Maybe
It's a physical security
Yeah,
right? We're
I'll go-
focusing on physical security
Yeah,
this
yeah.
time, right? So we tried to, Mike tried to make it much like a real lock with the same attack available.
Yeah, maybe I'll go talk to the lockpick community about it.
There you go. Talk to them.
Yeah. Right, you guys got anything else?
Got questions?
Yeah, questions, please.
So the badge, if hypothetically someone tried to rewrite the NFC on it, and then your contact information disappears, how do you re-flash the NFC on it?
I'm surprised you were able to get the contact information.
Agreed.
There's like a magic string that needed to be in there for it to rewrite that.
No, I wrote something, and I get the schedule.
Oh,
So you should get the schedule, and then you have to open the class to get the V card.
Yeah, no, that goes away.
Okay, yeah, we could try to reflash that and fix it.
Okay.
But that's impressive. Sorry, I guess he didn't have a mic. His question was he broke the V card by writing NFC to it, and that's what he asked how he can fix that.
Okay. Oh, there it goes. So my biggest question is, what in your decision, like, because there are lots of, I guess, different options we could have gone with, like, I guess my thing is like a Raspberry Pi Mini or an Arduino or something like that that has a lot more, I guess, build behind it. What was the decision for you guys to do your own chips and do your own programming there, opposed to using something that's more mature or even developed in that area?
It's a great question. So things we run into, Arduino is great if you're using one of their exact models that they fully support. Otherwise, you're on whatever community support is based around the chip for it. The other thing is Arduino doesn't really have debugging, which is a huge thing. So when you're using, the manufacturer's IDE, you get actual step-through debugging, and so that's a big thing for why we don't go with Arduino. Raspberry Pi stuff is super expensive and hard to get in large quantities.
It also kills batteries
That too.
really fast.
There was a SAINTCON year that did the Raspberry Pi, and Troy pulled a lot of strings to get that many Raspberry Pis
Yeah.
at one time, and it was basically like, yeah, that's not happening again.
Yeah.
So first of all, thank you. The badge is amazing. I love how it integrates with everything. Like it integrates with all the different villages or whatever, and it's just a really fun badge that it integrates with the rest of SAINTCON. But my question is there anything cool that happens when you build the machine? Is it just kind of personal gratification, or is there something special that unlocks you?
Yeah, that's really all it is. We didn't make it to that. Like there was thoughts, but we never made it past that. So you don't feel obligated to build it at all. But that's all there is to it. Sorry.
It looks really cool, though. You did a great job on it.
Yes. Okay, other questions? Or complaints, we'll take those too.
Yeah.
I mean,
Feedback is very welcome, so we
Yeah.
don't make the same mistakes every year.
Yep.
So that's something that's really quick. So in other years, we've had, there's been a lot more badge assembly for, the actual, attendees versus, this year where a lot of it was already pre-done. Is there any plans in the future to kind of bring it back to more attendee assembly versus pre-assembly stuff?
Are you saying you like assembly yourself?
Yeah.
Okay.
Yeah, so that is actually in the works for hopefully next year, a little more arts and crafts badge. It's been talked about because poor Troy, I've taken over his house every year for a week doing assembly, and him and a bunch of committee members coming over there and assembling badges for days. So yeah, we're gonna hopefully go to more attendee assembly in the future. But here again, we get lots of complaints the other way of, I don't want to solder this, I don't have time for this, why do I have to do this? So yeah, we'll try to switch it up and do a little more of that next year.
Maybe have a minimal functioning badge without solder, but add on options.
Oh yeah, that'd be cool.
Another trade-off that we have to make is if we want to make something you can solder yourself, traditionally there have been pre-built boards that you have to assemble together, which is really big and bulky. Or you have to go with what already exists, and traditionally those boards are not as power friendly.
Yeah.
They're meant for for prototyping, and then that's it. They're a do-all, and if you want your badge to last, doing surface mount, keeping it small, tends to be a little bit better, at least in my experience.
Yeah.
Do you guys have any chips that you really want to use on a badge, but you haven't been able to force in by, for any reason?
Yeah.
Sorry, no secrets.
This year, I really wanted to use the new Raspberry Pi. Is it not the
The 2040,
yeah,
the Pico.
Pico, that's the one. But getting them in quantity wasn't an option. It is now, but months ago it wasn't an option. So maybe next year, who knows? Right. Any other questions? We got one back there. There you got one. It's mainly for the video that'll be up on YouTube later.
So I've gotten 2 unlock codes so far, and both of them shared 2 numbers. Is that a coincidence, or is there some kind of a pattern that I can figure out to get more unlock codes?
The combination unlock codes?
Yeah.
So they are valid master lock unlock codes, and master lock unlock codes do have a certain pattern,
Okay.
but there's no more similarity between the numbers than that. So you shouldn't be able to deduce one from another.
Sure, okay.
But I've said this to a few others, the badge, when you're entering the numbers, after you enter the first number, if you're like 1 off on the second number and then you move, it will fix the second number to one of the known combos. So it's going to cheat for you a little bit.
Oh,
if you're
okay.
trying to enter a wrong combo and it keeps changing it for you, that might be a good hint that that's not a combo.
Okay.
That may help you to do some more, but that's not the intended method. But nonetheless, I'm not going to stop you from trying.
Sure, thanks.
Cool. Anyone else?
When you guys are working,
Yeah.
when you guys are trying to work together, how much, because you all are so competent, how much do you have to avoid stepping on each other's process?
I don't think we do. I don't know.
Yeah, I didn't feel like there was any much of stepping on anybody else. It was mainly like, whoever can get to this first, let's just do it.
Yeah.
Yeah.
So much development work to do. Yeah, it was whoever had some time, jump on it and get it done.
Obviously, each of us have kind of some core competencies, and so we each
Yeah.
kind of did what we know best, but the areas which kind of overlapped, it was just whoever got to it first just did it.
Yep.
Do you ever get that when you're actually working? Or is it just when you're doing hobbyist work?
No, I get that, like overlap on, I don't know. Sorry, can you ask the question again?
When you're at work, do you feel like there's better flow between hobbyist projects that you want to work on, or do you feel like there's more overstep when it comes to clocking in and having to do something?
For me, the experience is the same. The guys I work with, they're top quality as well, right? So I feel like we work well. Maybe they don't feel the same about me, but I feel like that they do.
Cool. Anyone else?
Any last questions? Hey, I just want to say, I don't know if you realize the amount of hours that these 3 up here have put into this badge. They have put hundreds and thousands of hours into making this badge. So if we can just give them a huge hand of applause.
Thank you.
Thank you, guys.